Okay, good morning, students. So now we will see that the division of currents in parallel circuit. Okay, so here when two resistors are connected in parallel, so here we will consider the two resistors, that is R1 and R2, are connected in parallel as shown in the figure, and the voltage across the combination. So the step one is let the current in a circuit of let the current in the circuit of resistance R1 and R2, that is I1 and I2 respectively, since the potential across the each resistor is same. Okay, so we know according to the Ohm's law, I1 is equals to V by R1, as it is a parallel connection. So we know the voltage across the both the resistance is same as the supply voltage. So here I1 is equals to V by R1 and I2 is equals to V by R2. So here we are placing this is as equation 1 and equation 2. So now divide equation 1 by 2. So I1 by I2 is equals to V by R1 divided by V by R2, which we will get R2 by R1. Hence, the current in each branch is inversely proportional to the resistance. Okay. So, I1 by I2 is equals to R2 by R1. So, from this we can tell that the current is inversely proportional to the resistance. Okay. And we know that the current in parallel circuit, the total current in the parallel circuit is I is equals to I1 plus I2, addition of the all the branch currents. Okay. So from this, from equation 4, I can calculate I2, that is I2 is equals to I minus I1. Now here what I'm doing, I'm substituting this, I'm placing it as equation 5, and from equation 3, so from equation 3, that is I1 by I2 is equals to R2 by R1. From there I'm taking only the I1 value. So I1 I will get I1 is equals to R2 by R1. This I2 will go here. Okay, so R2 by R1 into I2. So this I'm placing as equation 6. So substituting I2, this I2 in equation 5. From equation 5, okay, this I2, that is equation 5, I'm substituting in equation 6. So here, now I2 I can replace it as I minus I1. Okay, so I1 is equals to R2 divided by R1 into I minus I1, which we will get R2 by R1 into I minus R2 by R1 I1. Okay, so here which is equals to, so this part I'm sending to the left hand side. Okay, so I1 is equal, because we need to calculate I1, total I1. Okay, so I1 plus R2 by R1 into I1, which is equals to R2 by R1 into I. So here I'm taking the common I1. So I1 I'm taking common, so I1 into 1 plus R2 by R1, which is equals to R2 by R1 into I. So this R, I'm doing the LCM like part, like, so this R1 will go here. So R1 plus R2 divided by R1 is equals to R2 by R1 into I. So what is the value of I1 finally? So I1 is equals to I into R2 divided by R1 plus R2. So this part you have to know. So I will say here. So I1 is equals to R2 by R1 into R1 divided by R1 plus R2. Okay, so here what happens? This R1 and this R1 will get cancelled. So the final into I, right? So finally what we will get, as this R1 will get cancelled, we will remain only with R2 divided by R1 plus R2 into I. Okay, so that is only here. So I1 is equals to I into R2 divided by R1 plus R2. So this is a formula how we will calculate an individual current without voltage. So when we will utilize this type of formulas is when when voltage is not given, only resistance value is given and total current is given. At that time we will go for this formula. Okay, so here if we want to calculate I1, so I1 is equals to total I into R2 divided by R1 plus R2. Likewise, you have to calculate even I2 formula. How we have calculated I1 formula, like similar process you have to follow. You have to calculate I2 formula. For I2, what we will get is I2 is equals to I1 into R1 divided by R1 plus R2. So now we will see the example 3. Okay. So here a 100 watts 250 volts lamp is connected in series with a 100 watt and 200 volt lamp across 250 volt series. So here they are asking to calculate the circuit current, voltage drop in each lamp, and assume the lamp resistance in remain unaltered. Fine. So here there are two lamps connected in series. Lamp 1, lamp 2. See, for any problem, you have to first analyze the question, and after analyzing the question, you have to draw the circuit diagram. Circuit diagram will help you in solving the answer easily. Means it will understand that you could able to solve the answer with the diagram easily. Okay. So here one bulb has 200 volts 250 volts lamp. I mean 100 volts 250 volts lamp. Okay. So now this is 100 watts lamp and which is of 250 volts. And which are connected into again 100 watts and it is the power, the voltage rating is 200 volts. Generally when you go out and when you purchase the bulb, that bulb will be available in the power rating. We will ask the person to give a bulb of 100 watts or 200 watts, likewise we will say, and in that rating only even the voltage rating will also be available. Okay. And these two lamps are connected in series and connected to a supply voltage of 250 volts. So now our source voltage is 250 volts. So we have to calculate the current flowing through the circuit and the voltage drop, that is what is V1 and what is V2. So voltage drop across each lamp. Okay. And assume the lamp resistors are remain unaltered. So provided you have given that R is unaltered. Okay. Right. So here you have to write first when you are solving any problem given data. Circuit diagram and given data is must. Okay. So the given data is 100 watts, 250 volts, and again 100 watts and 200 volts. And the supply voltage V is equals to 250 volts. Okay, this is a given data. And you have to calculate total current I and R1, R1 no, V1 and V2. Okay, this you have to calculate. Now before that you have to calculate the resistance value. What is the resistance of this lamp and what is the resistance of this lamp? Okay, so you have to calculate the resistance of each lamp. So we know that uh, P is equals to V into I formula. Okay, so here P is nothing but that is a power which is in wattage. Okay, is equals to V into, in place of I, what I will do, I will substitute I is equals to V by R formula. Okay, in place of I am directly substituting the formula V by R. So from this I will get V square by R. That is not V 2 it is V square. Okay, so V square by R. So now we have to calculate the resistance. So we have the given data is the power and the voltage. We don't have current. Okay, so that given data is power and the voltage. We have to calculate the resistance value. So the resistance formula is R is equals to V square by P, that is power. Okay, which is equals to, now we have to calculate each resistance formula. So here for first branch the wattage given is 100 watts and 250 volts. So 250 volts square, 250 whole square, okay, divided by P, that is 100. So 250 into 250 divided by 100. Divided by 100. Okay, so what we are getting, it is 625 ohms. It is, as it is resistance, it is ohm. This is first resistance, so I am placing it as R. Okay, so the first resistance value is 625. Okay, so now we have to calculate the second resistance value. The second resistance value, that is R2, which is equals to again V square by P. Okay, now what is the voltage of the second one? That is 200. Okay, so it is 200 square divided by the P is again 100 watts only. So we have to calculate this. So 200 into 200 divided by 200 into 200 divided by 100. So this 0 and this 0 will get cancelled. Then it will be, remaining will be 400. So 400 ohms is the second resistance value. So now you people have got R1 and R2 values. You can calculate the total resistance value. That is R is equals to R1 plus R2. Okay, which is equals to 625 plus 400, that is 1025 ohms. Okay, so now you got total resistance. You have to calculate the total current value. Okay, so I is equals to V by R, that is total resistance. So which is equals to, what is V? V here is the supply voltage, that is 250 divided by R is 1025. So you will get the current is equals to 0.244 amps. So you got current. Now you have to calculate V1. So V1 is equals to I1 into R1. Okay. So what is I1? It is, as it is series circuit, I1, as it is a series circuit, I is equals to I1 is equals to I2. So here it is 0.244 into R1 is 625, which is equals to, so 625 into 0.244 is equals to, so the here the voltage is 152.5 volts. Likewise, you have to calculate even V2, that is I2 into R2, which is equals to 0.244 into 400 is equals to 0.244 into 4, sorry, 0.244 into 400, that is 97.6 volts. Okay. So here you got V1 and V2. So that is what they asked, that what is the total current. So total current you got, and V1 you got, and V2 you got. Okay, sometimes you people have may get that whether you have got the calculated voltage is correct or else not. So for finding out that, the formula V is equals to, in series connection, the formula V is equals to V1 plus V2. Okay, so you can directly substitute the values from that. This should be equivalent to the supply voltage. Okay, this is for cross checking, no? So 152.6 plus 97.6 is equals to, so 250. It is approximately 250. So that is the supply voltage. Okay, the supply voltage is 250, right? So it should be equal to the supply voltage. Drops must be equal to the supply voltage. So it has tallied the voltage. So the problem, the values what we have got is correct. This is only for analyzation. Okay, it is a cross check at your end. So this is how you have to calculate the problem. So now here we will check out the current division problem. That is an example 2 here. And find the current in each resistance of figure given. So here in the figure, we could able to see that 5 ohms and 10 ohms and 15 ohms are connected in series. And this is a total, current. And it is, the 3 resistors are connected across a 50 volts. So we have to calculate the current I1. Okay. I1, I2 and I3 also. So we know that uh, we have to calculate individual currents. So for calculating individual currents, first we have to calculate the total resistance, then we can calculate the total current. So for calculating the total resistance, we know the formula total resistance R when three resistors are connected in series, that R is equals to R1 into R2 into R3 divided by R1 R2 plus R2 R3 plus R3 R1. Okay, substitute the values directly. Then we will get the answer, that is 2.727 ohms is a total resistance. Okay. So here now we got the total resistance. We have to calculate the current I. I is equals to V by R, which is equals to 50 divided by the resistance. So we will get 18.333 amps. Okay, so now we got here the total current amperes, and now we have to calculate the individual current. So according to the current division formula, I1 is equals to I into R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1. So substitute the values which we have already know. So directly we will get the answer is 10 amps. So I1 is 10 amps. Likewise, the current which is passing through 10 ohms resistor is I2 is equals to I into R3 R1 divided by R1 R2 plus R2 R3 plus R3 R1, which is equals to I is 18.333 into R3 is 15 and R1 is 5 divided by the, here the total resistance with the calculation it is 275, which we will get it is 5 amps. Okay. Likewise, the 15 ohms for the current which is passing through the 15 ohms resistance is 3.33 amps. So we have calculated I1, I2, I3, and we calculated already I. But for cross checking the value of the whether you people have got the total resistance, or mean individual resistance currents value is correct or not, you individually you calculate that I1, I2, I3, so that we will get 18.33, which is equal to the total current formula, I mean total current which we have already calculated. This is like a cross check point. Okay, so this is how you have to calculate when the three resistor or two resistors are given. Okay.